This is the presentation of the part 2 video using LDA for exploring the Pokemon dataset. Linear discriminant analysis, which is the goal of this application is to predict the type of Pokemon based only on its stat totals. Okay, let's start the application. The import of Panda is done in line 2. In line 3, the dataset Pokemon.csv has been imported, and we can see the Pokemon data with 3 rows and 41 columns. Now we are going to focus only on Pokemon with a single type, which is no dual types allowed. Here we are normalizing the data before applying LDA. Normalization is a pre-processing step in order to make the class coefficient large, which is and a bit easier on the eyes. After that, assessing class-wise variable importance using LDA coefficients is showcasing the heat map that follows demonstrates what this map out to. In this heat map, we see classes which are probably easier to separate given their large variable coefficients, as well as classes which are probably much harder. A separate class is the rock type Pokemon. This one, rock type Pokemon load very strongly on all special attack, special defense, speed, and SP, implying that combination of these stats makes up the rock archetype. Other highly separable classes are ghost type and the fighting type. Ghost type, fighting type, which both sport some high magnitude coefficients. Ice and water are two classes that have a very low class separability. They both have coefficients that are mostly close to 0. We can summarize this heat map by looking at the absolute coefficient total for each of the classes. Here. Again, we see that the rock and ghost is much more separable. As you can see, the ghost is less than 80 and the rock is more than 100. And the water and ice is less than 20. So rock and ghost is much more separable than water and ice. To see what these different translate to add and to understand how well we perform overall, we need to move on to applying our LDA. Okay. Assessing linear classifier performance by applying the LDA projection. LDA picks values that maximize the difference between classes, so the explained variance ratio will not correlate exactly with the usefulness of this or that particular vector. However, in practice, LDA creates axes which are reasonably close to axes created by PCA. This is a convoluted mess. What we have learned that different classes of Pokemon are not very linearly distinguishable by stats only. In summary, this plot tells us that classifying Pokemon using stats alone is a non-linear problem. As you can see, all data are stacked almost all together, with some exceptions in the green, which is fairy, and very less on the outside, and all of it in the inside. This in turn tells us that given the current set of features, predicting Pokemon type is a very hard classification problem. Most problems that are not linearly separable are very hard unless there are unusually complicated data deficiencies like spiral structure, or we are able to gather additional useful features. Domain knowledge in Pokemon tells us that this is probably true, so in a sense this is something already new. In fact, the very concept using PCN in as you can see with this demonstration that the classifying Pokemon using stat is a non-linear problem, and this in turn tells us that given the current set of features, predicting Pokemon type is a very hard classification problem. In conclusion, LDA is a LDA is a dimensional reduction technique, which is a first tool of choice when working with classification tasks. As an EDA technique, it tells us a lot about the complexity of our problem and tells us which classes are most easily distinguishable and why. As a pre-processing technique, it improves model performance for any useful model we apply to the dataset afterward, but particularly for linear ones like SPM.